We're going to find the volume of a solid obtained by rotating a region bounded by the parabola y equals x squared plus x plus 1, the line y equals to 4x minus 1 about the y-axis. There are two methods to solve this problem. The shell method, which will be shown in the next video, and you should look at that to compare, and the washer method, which we'll do in this video. You'll see the washer method is somewhat more complicated, and you can compare the two methods. Sometimes one is easier, sometimes the other one is easier. First step is to find where these two intersect, so we're going to set them equal to find the x-coordinates of the points of intersection. X squared minus 3x plus 2 equals 0. X minus 1 times x minus 2 equals 0. X equals 1 or 2. Plugging those into the either line or parabola, the points of intersection are 1, 3, and 2 and 7. Now pick a point between 1 and 2 for x. Let's x be 3/2. If I plug 3/2 into the parabola, y is 9 over 4 plus 3 over 2 plus 1. That's 19 over 4. If I plug it into the line, y is 4 times 3/2 minus 1, which is 5, and that is 20 over 4. So you can see the line is higher than the parabola. Once we know that, we can now sketch this region without too much difficulty. We don't need to worry about the parabola, just the part that we need. So this is point 1, 3. That's one point of intersection. This is point 2 and 7, the second point of intersection. We just saw that the line is higher above the parabola by plugging in 3/2. So this is what our region looks like. Looks something like that. Now if I pick a typical y between 3 and 7, any arbitrary y between 3 and 7, and keep track of a horizontal slice of the area, as it rotates, it generates a washer. And finding the area of this washer as a function of y is the key to solving this problem. So recall, when we have a washer with inner radius little r and the big radius big R, the area between the two circles, the area of the washer, is pi times big R squared minus pi times little r squared, or pi times big R squared minus little r squared. The key here is to express the big radius and the small radius in terms of variable y. Right now they're expressed, where the functions are expressed for y in terms of x. We have to change that to express them for x in terms of y. For the line, it's not that hard to do. We add 1 to both sides. Y plus 1 is 4x. X equals to 1/4 y plus 1/4. For the parabola, we're going to complete the square first. The coefficient of x is 1. Dividing it by 2 is 1/2. Squaring it is 1/4. So we add 1/4 and subtract 1/4. Now the first, the second, and the fourth term form a perfect square, which is x plus 1/2 squared, and the remaining two terms, 1 minus 1/4, give us 3/4. Now subtracting 3/4 from both sides, y minus 3 over 4 is x plus 1/2 squared. Taking square root of both sides, x plus 1/2 is plus or minus the square root of y minus 3 over 4. X equals minus 1/2 plus or minus the square root of y minus 3 over 4. Now notice that on the graph we have the right part of the parabola. The right part of the parabola, that means we're going to take the plus. It's described by the equation x equals minus 1/2 plus y minus 3 over 4. So let's sketch the region again, and we'll be able to express big radius and small radius as functions of y. This is what the region once again looks like. We have point here of intersection, and the second point is there, connected to by a line and by the parabola. That is 7 and this is 3. This portion, the parabola, is x equal to 1/2 plus or minus 1/2 plus the square root of y minus 3 over 4. And the line is x equal to 1/4 y plus 1/4. So now if this is my y, the big radius would be from here to the parabola. That's big R. And the small radius would be right over here to the line. That's a little r. Therefore, our volume will be pi times the integral. We're taking y's from 3 to 7. And then the big radius, that's minus 1/2 plus the square root of y minus 3 over 4 squared. That's big R squared minus 1/4 y plus 1/4 squared. That's a small radius dy. That's the integral that will solve this problem and give us the volume of our solid. So now let's simplify it. Pi times the integral from 3 to 7. Squaring the first part, the parabola part, we get 1/4 minus the square root of y minus 3 over 4 plus square root squared, which is y minus 3 over 4 minus 1/16 y plus y squared plus 1/8 y plus 1/16. We have a constant over here, 1 over here, and then 1 over here. So let's combine those two. 1/4 minus 3 over 4 is minus 1/2, or minus 8 over 16 minus 1 over 16. The net is minus 9 over 16 minus the square root of y minus 3 over 4. Y minus 1/8 y, it will be 7 over 8 y minus 1 over 16 y squared dy. And now let's go ahead and integrate. Each of these are not that difficult to integrate. We have pi times minus 9 over 16 y minus 2/3 y minus 3 over 4 to the 3/2 plus 7 over 16 y squared minus 1 over 48 y cubed. And this is evaluated from 3 to 7. So let's plug in 7 for y. First, we have pi times minus 63 over 16. Plugging 7 for y in here, that gives us 28 over 4 minus 3 over 4, 25 over 4. Take the square root of that, we get 5/2. Cube that, 125 over 8 times minus 2/3, that's minus 125 divided by 12, plus 343 over 16 minus 343 divided by 48. Plugging 3 in, we end up with minus 27 over 16. Plugging 3 into the 3/2 power term, we get 12 over 4 minus 3 over 4, 9 over 4. Square root of that is 3/2. Cube that, 27 over 8 times minus 2/3, that is minus 9 over 4, plus 63 over 16 minus 27 over 48. So the common denominator here will be 48, and we can draw a big line like this and put 48 down here. So to get everything to 48, we'll have minus 63 times 3 minus 125 times 4 plus 343 times 3 minus 343. Minus a minus will be plus 27 times 3. Once again, plus 9 times 12 minus 63 times 3, and finally plus 27. And so combining this together, we end up with the following. The final answer. Pi times minus 108 minus 500 plus 1029 minus 343 plus 81 plus 108 minus 189 plus 27, and this is all divided by 48. So if we add these up, we have pi times the positive terms here in this list add up to 1245, so that's 1245. The negative terms add up to 1221 divided by 48, and of course this is 24 pi divided by 48, and finally we arrive at the final answer. The volume of this solid is pi